I'm Earl Ward, the Northeast Area Livestock Specialist for Oklahoma Cooperative Extension Service. In this video, I want to emphasize the importance of obtaining a forage analysis and how we can use that information to determine the best course of action for supplementation. The largest majority of our cattle operations are forage-based systems, meaning that producer needs to rely on either standing forage or hay bales to provide the majority, if not all, of the nutrients required for adequate production. However, we know that these nutrient values for these forages can vary greatly, and that we only can be certain if the quality is with a lab analysis. The first step is to collect a forage sample that represents as much of the field as possible. It's our recommendation that each pasture or source of forage be tested separately due to any variation in nutrient density. The good news is that if you get your hay from all one location, you only need to obtain one sample. The hay sample can be obtained just prior to baling by just grabbing a grab sample sporadically across the field. If the forage is already in a bale form, your best option is to obtain a hay probe. Here in Oklahoma, our county extension offices have hay probes that they will loan you to producers free of charge. We recommend that if you're sampling small square bales, that you get at least 20 random probes, or 10 random probes if you're sampling large round bales or large square bales. If you're sampling square bales, we recommend you insert the probe from the small end. And if you're collecting on round bales, we recommend you insert the probe on the round side. By doing so, you ensure that you're representing a large surface area of the field. And if you get a grab sample or use a hay probe, mix that forage sample up well and take it to your extension office or send it off to the lab of your choice. If the sample is chopped up, you'll need approximately about a half a gallon bag full. If it's not chopped up, we recommend bringing in about a gallon bag full. This slide shows an example of the forage analysis we do here at Oklahoma State. As you see, there are 3 columns of numbers. First one being a dry basis, which is with all the water removed. As received, which is has the moisture included, and as fed, which assumes 11% moisture content. Of these 3 columns, the only one I'm interested in is the dry basis column. The reason I'm not concerned about the as received or as fed columns is because the moisture content will affect these numbers depending on the moisture level. However, the cow is going to remove the moisture from the forage anyway, and this allows us to compare apples to apples if everything is on a dry matter basis. The first thing I look for in the analysis is the dry matter percentage. I use this number to determine whether this sample is a dry hay or some sort of haylage, baleage, or silage. I can also use this number to calculate the actual pounds fed at the end of formulation. The next thing I look for is the crude protein percentage. Crude protein is simply the measure of the amount of nitrogen in the sample. What we do is we take the percentage of nitrogen, multiply that times 6.25, and it'll give us the percent crude protein. It's important to note that animals require pounds of crude protein, not percentages. For instance, a 1,200 pound lactating cow would require 3 pounds of crude protein daily. Therefore, if the cow is eating 30 pounds of dry matter a day, the forage would need to be at least 10% crude protein to meet her requirements. The next thing I look at is the percent total digestible nutrients, or TDN. For beef cows, this is our best estimate for energy and quality of the forage. This value is calculated based off of the acid detergent fiber the sample contains. The ADF is the measure of lignin in the forage, and lignin is indigestible. Therefore, the more lignin, the higher the ADF value, which means the lower the TDN value. A 1,200 pound lactating cow would require approximately 17.6 pounds of TDN a day. So again, if she's eating that 30 pounds of dry matter daily, the forage would need to contain at least 58.6% TDN to meet her requirements. On this graph, there are 48 forage samples that were reported in Payne County, Oklahoma in 2017. These samples are graphed based off of their crude protein and TDN values. As you can see, we have several samples that are low in quality and several samples extremely high in quality. If we're looking at just the crude protein values, any forages in this little yellow box would meet lactating cow's protein requirements. And if we're looking at the TDN values, Any forage in this blue box would have a higher energy values and meet the same cow's TDN requirements. What this comes out to mean is that any sample within this box would need both crude protein and TDN supplied. Any forage in this box would meet the cow's crude protein requirement, but we would need additional supplementation for energy. Any forage in this box would meet the cow's energy requirements, but would need a supplemental protein. And lastly, the forage in the upper right box would be able to meet a cow's crude protein and TDN requirements with no supplementation. And a couple of these samples would be providing too much protein. We have some producers who only send their samples in for crude protein analysis and believe that it's a good indication of forage quality, but in fact, the percent crude protein is not related to the TDN value. For instance, if we look at this green bar, we see two samples. They're pretty close in crude protein, but drastically different in TDN. As a nutritionist, I need both the crude protein and TDN values to be able to assist producers with the most economical supplemental option. Every year we get the question, what do I need to feed my cows this year? And that question should be answered based off of the producer's forage analysis and the current prices of the supplements available to that producer. On this graph, I show three different retail products, a 14%, a 20%, and a 38% cube, with simple calculations show which supplement best fits each forage analysis economically. Remember, there are several forages towards the right of this graph that do not need any supplementation. Now, these recommendations for these supplements are going to change year to year based off of next year's forage analysis and supplement prices. Here in Oklahoma, especially eastern Oklahoma, the most common supplement used is a 20% cube. Many producers have the concept of if it ain't broke, don't fix it. And they've gotten along pretty well with that philosophy, but it has most likely not been the most economical supplementation. In this graph, I show the cost savings from switching from a 20% cube to either a 14 or a 38% cube. This graph shows the savings of a 50 cow herd over a 100-day feeding period. As you can see, there are several operations that would financially benefit from using the most cost-effective supplement based off of their own forage analysis. I hope this short talk has helped explain the importance of taking annual forage samples. I hope it demonstrates how to use the forage analysis to determine the most economical supplemental strategy. And I hope that you use your extension educator to help you develop a plan to utilize your resources to their full potentials. If you have any questions, please feel free to contact me and ask.